Two-sided marketplaces are a great way to resolve supply and demand inefficiencies. There is such high demand for great programmers, but there is only a limited supply. So why would it make sense for a great developer to use a terrible tool like a job search engine? That's why I love Hired.com. Developers can sign up at hired.com/softwareengineeringdaily and be connected with 5 great job opportunities at companies like Stripe, Uber, and Facebook. If you're a developer, you shouldn't settle for a mediocre job. I know this from personal experience. It will stunt your career growth. Hired will give you a $2,000 bonus if you find a job. And if you go to hired.com/softwareengineeringdaily, you will get an additional $2,000. It costs you nothing to try it out, and it's a fun process. I urge you to try it out. Kelsey Breseman is a core contributor and steering committee member on the Tessel Project. Kelsey, welcome to Software Engineering Daily.
Thanks very much.
What is Tehsil?
Tehsil is a small device that lets people build smart devices quickly, even if they don't have any electrical engineering expertise. Essentially, it's targeted for web developers to build physical things, and we found that it's not an easy proposition to get a web developer to build their first physical electrical device, because there's a lot of barriers to entry, particularly with regards to magic smoke. Nobody wants to buy parts on the internet, wait for them, hook them together, nervously plug it in, and have the whole thing blow up and get nowhere.
What is magic smoke?
Sorry, that's a technical term, I would say. It's when something literally burns out of your electronics and no longer works. The magic would be the part that makes it work, and it's no longer inside the chip.
Interesting. So the founders of Tehsil were originally web developers. It sounds like that affected their approach to hardware.
Yeah, absolutely. And it's kind of a fun story. The three of them, that's Tim, Ryan, Jalia Huang, and John McKay, got together on a project in their senior year of college, and they were assigned to build physical devices to extend the presence of the web. And they said, well, this is great. We're smart people. We're engineers. We do web development. How hard can it be? And they started doing stuff with the available tools, including Raspberry Pis and Arduinos and such, and just said, this is silly. This is not easy. The tools aren't built the same way that web developer tools are. The cool thing about web development is that the people doing it are also the people building the tools for the people doing it. Like, fundamentally, it's writing software to write software. And so there's a lot of innovation in that space. In the electrical engineering world, it's just not the case in the same way, because the people using the tools are not software writers. And so their tool sets can just get ridiculously out of date. And so you don't get the same kind of user experience. And so they came in and said, well, what if we applied software engineering web development principles to hardware? First off, let's make easy app interfaces that work with the tool sets that we understand. And secondly, how can we draw principles like modularity and open source and building on each other's work like NPM modules? How can we draw that into the hardware world?
Yeah, and historically, hardware development has been more complex and more difficult than web development. Is there anything about hardware development that really makes it inherently more complex than web development, or is this just a function of the tools that we've had historically?
That's a really good question. And I think there is definitely some inherently complicated stuff about hardware or about electrical engineering. I think the single biggest blocker is just the fact that you have to have physical things, which means time and money that isn't required in web development. I think the biggest example for me is when you're producing a version of a PCB, that's a printed circuit board. You're going to spend a lot of money to make like maybe 5 of them, which might not be consistently manufactured, especially if you got it turned around rapidly. And rapid turnaround is like 2 weeks later. Can you imagine if you were writing your JavaScript code and you had to wait 2 weeks to like run it? And then like it wouldn't run the same every time because maybe somebody else screwed something up.
Yeah.
And so like there's a lot of fundamental complications in terms of why hardware and software are not the same. But that doesn't mean that they have to be approached in a fundamentally different way. It means that you need to be able to specifically create hardware constructs that can be iterated on more rapidly, such as with Tessel's plug-and-play modularity or hardware module system. Does that make sense?
Yeah, absolutely. I completely understand. I think I would probably quit being a developer if it took me 2 weeks to run my code. Tessel runs JavaScript. Why is this an advantage?
There's a number of reasons. The first and most obvious reason is that we come from web development, and that's the language of the web, de facto. The other piece, though, is as we grew, it was less about letting web developers make stuff and more about letting people make stuff in an accessible way. One of the awesome things about JavaScript is that it's so rapidly growing, and there are so many tools for people to learn it. So you end up with a much bigger audience of people who will be able to use this platform. And I guess a better way to approach that would be fundamentally a high-level language is cool. It means that even if you don't speak that language, even if you don't write JavaScript every day, maybe you're a C programmer or maybe you write Java, you can read it and figure out what's going on, which is not the case if you're a JavaScript programmer trying to learn C++.
Or if you're trying to learn like register transfer language or one of these, I'm trying to think of, I took like an electrical engineering class in college and it was the worst class that I took in my, the entire duration. I remember whatever language we were writing in was certainly much more indecipherable than JavaScript. So do I only have access to JavaScript if I'm programming for Tessel, or is JavaScript just the main API?
JavaScript is what we explicitly support. Tessel 2, so Tessel 1, you could only write JavaScript unless you really wanted to circumvent our systems because it used a JavaScript to Lua transpiler. Tessel 2 actually is a Linux box, so you can do whatever you want on there. And what we're building is support for Rust and Python languages as well on there. Though JavaScript is still definitely the primary, we'll have some blinking examples and directions to go for Rust, Python, and honestly, any other language you want. It's fairly trivial to build an example of how to do it and go from there.
Are there some applications where speed has been more of a necessity? Is that why the motivation for Python and Rust?
That's a good question. I think that Rust is exciting because it draws in people who generally aren't interested in JavaScript devices. It's sort of a proving point for Tessel's a cool piece of hardware, and as an electrical engineer, you should be able to recognize that as well. But we have found that a lot of people who are traditional hardware people, or even people who have done a lot of stuff with Arduinos, are kind of turned off by like, this is JavaScript. This is not the real thing. It's not close to the metal. But Rust, like if you're a Rust programmer, you probably know what you're talking about in terms of hardware, at least to a degree.
Well, Rust is by definition close to the metal.
Mm-hmm. Good pun if you meant it.
Yeah, that's exactly what I meant. That's all I meant. Why did you choose Rust instead of Go?
I honestly think it's because Rust was more exciting to the people working on it.
Oh, fascinating.
Which is, I guess, how open source projects tend to work. And honestly, that's also why development so far on the Rust and Python support for Tessel 2 has been a bit slow to pick up. Most of the people who are excited about the project are used to writing in JavaScript. And so that's what gets worked on the most.
So how is Tessel different from Raspberry Pi or Arduino?
I think the biggest difference is the user experience that we bring to it. The way that you work with an Arduino or a Raspberry Pi, it tends to require some specialized knowledge, some learning curve, some need for mentorship usually. There's typically quite a bit of frustration when people are just getting started with Arduinos and Raspberry Pis. And honestly, I haven't used one in a couple years since we came out with Tessel, so I'm speaking with somewhat outdated knowledge of those. But part of the point of Tessel is that it just works. Like, you don't have to worry about it. Much in the way that you would throw your app up on Heroku.
Yeah, it sounds like the Ruby on Rails of hardware programming.
Yeah, that's kind of the idea. And actually, so I wrote our first run experiences, the original one for Tessel 1 and the second one for Tessel 2. And the whole point of these first run experiences, it's just a tutorial that gets you started with, oh, what is this? How do I push code to it? Like you'd expect with a platform. And when I wrote them, my goal was, how do we get people functional as fast as possible? Which doesn't mean let's learn exactly how every part of it works or let's learn every piece of the API. It was, how do we get people from having no idea what this hardware thing is to, okay, I made a thing that interacts with the internet and with, say, whether or not I'm clapping. And I tested that out yesterday, actually. I spoke at Node Interactive yesterday, and I had a session, but it was much bigger than I expected, so I didn't have enough hardware. I meant it to be a hands-on hardware workshop, and ended up giving a talk, but I still wanted the hands-on hardware workshop. So I put instructions out on the tables to go to my first run experience link and some Tessel 2s and said, hey, go here and figure it out while I give my talk. So it was a simultaneous workshop. And it was pretty cool because in that, 20-minute talk, at some point, like 15 minutes in, I looked over and was like, hey, over there, are you guys doing okay? Is that all working? And they all looked up and they were like, yeah, this is working. Which was awesome. It was like, yeah, it was just like, without needing anybody walking around holding their hand, which is what I usually do at these kinds of workshops. They were able to go from no hardware. I mean, this is a web developer conference, and they were just making hardware stuff no problem.
Yeah, when you're having conversations with people at Node Interactive, what kind of feedback are you getting?
People are pretty intrigued. I'm sure I don't get like the entire impression because they're mostly saying, "Oh, that's cool. What are you doing?" I don't know. You don't get a whole lot of depth out of most conference interactions, but I do get a lot of people coming up and saying, well, the number one response is, wow, that was way easier than I thought it would be. Or I've been meaning to try hardware and now I guess I will. That kind of stuff. And there's also people coming up and saying, oh, we've been exploring different hardware platforms and this one's neat. Can you tell me more about where you're going with this?
Yeah. So Node.js is event-driven. Why is the event-driven paradigm useful on hardware?
Waiting for events is what we do in real life. You don't just perform a set of tasks end to end. What you do in order to respond to a stimulus is wait for that stimulus. So, for example, I wait until I'm thirsty and then I go get a drink of water. So the event-driven would be when thirsty, get water. For hardware, it could be the same thing. Say you're making a thing that waters your plants automatically. You can have a sensor that is just waiting and waiting for a drop below a certain threshold of dehydration, and then when turn this on, and then when it's not, come back around.
Sure. No, that makes a lot of sense. So in the first version of Tessel, the JavaScript got transpiled to Lua. What was the reason for this?
Lua runs a lot faster than JavaScript, and that's the right person to ask for that would be Tim, who wrote it. But I've listened to him give this explanation a few times. Lua is a cool, simple language that works well with JavaScript. It's got a lot of similar structures, at the same time as being very small. And so it made sense to try it out and see if it would work, to build JavaScript to Lua transpiling. Of course, we moved away from that, not because it's an inherently bad idea, but because effectively we were rebuilding JavaScript, which you don't really want to do.
No, you don't. But when you move away from Lua, did you give up some speed, or was there some other compensation you made?
Well, part of the objective was to keep it very small, and be a microcontroller. And part of that is because a big piece of the excitement around a small connected device is that it might be low power and running off of battery, and you might have 1,000 of those in an office building or in a hospital or whatever. We moved away from that paradigm of it has to be small and super low power with Tessel 2, because it turns out that having Wi-Fi connectivity means that you're using a lot of power anyway.
Makes sense. So how has the Node community and NPM been influential in the design and development of Tessel?
It's been absolutely huge. I love the Node community. I think it's one of the most cohesive, inclusive programming groups there is. And I'm quite close to the NPM office. It's just in Oakland. I'm in Berkeley. So we know all of them. Basically, it was fundamental because we looked at that and said, well, this is modularity done right. This is good package management. This is a good way for, number one, it's open, so anyone can contribute some small library. Number two, it's very simple. You can do one-line installs without a lot of hassle. And so we built our ecosystem to work specifically with that and have our modules have actually on the silk screen, so written directly on the module is the NPM module name. So when you get a new module, say you get the relay module, you're going to type in npm install, and it says relay mono, because that's the chip, npm install relay mono, and then you have it. And you can go even further than that. We have community modules. We have people who want to hook up stuff from Adafruit and SparkFun, for a number of very good reasons, and we're really happy when people do. So maybe you want really precise temperature inside a pot of water. So you can buy a thermocouple for I think it's $10, and somebody wrote a library for that on NPM to work with Tehsil. And we didn't even have to touch that.
When you talk about modules, are you talking about hardware modules, or are they software that you're talking about?
It's actually a one-to-one mapping.
Okay, so there is a hardware for every hardware module. There is a software module.
Yes, correct.
Okay, and Tessel has 2 ports for modules. Could you talk a bit about a bit more about modules and how you can make modular improvements to the basic Tessel board?
Yeah. So the basic Tessel board has the processing unit on it. It has enough flash and RAM that you don't have to worry about memory constraints, and it has Wi-Fi built in. On the Tessel 2 in particular, it has the Wi-Fi chip out of a router. So you have your connectivity and your brains built in there. And then what you're going to want to do with that is interact with the actual world. And so modules are intended to be sensors, actuators, or additional connectivity types. So a sensor would be like a climate module or like an accelerometer, like in your phone, which can figure out how something is moving, or if you're usually in the case of your phone or applications like that, it's trying to figure out which way is down, which is really useful. So if you wanted to prototype a game controller, for example, or an actuator, for example, a servo motor, which I personally use to feed my cat. Though I also made this awesome WebSocket controlled robot car.
So I guess with your cat feeder, you can't actually say you're dog fooding the product.
Oh.
That's two puns, two terrible puns in the same show. That's a new record. Okay, very interesting. I mean, I'd love to hear some more about modules that people are using or modules that people have built that have surprised you.
Yeah, actually, the most interesting one with the most interesting module is the relay module, in my opinion. And relay is not a familiar term for most web developers, but it's just a switch that you can control programmatically. And what's cool about it is that you can take the things that already exist in the world, like canonically your toaster or your desk lamp, or literally anything that you plug into the wall. If you snip through one of those wires and stick those two exposed ends into the relay, it'll take over whether or not it's open and closed. So you can do basically anything with that. And I've seen users do some pretty cool stuff. So there was one guy who found out that the NFL actually has an API. And so he wanted, in order to throw really good football watching parties, he wanted to hook up his lamp to the API. And whenever they had a touchdown, all the lamps in his living room would just like spasmodically stutter.
Oh my gosh.
Which is beautiful.
That's funny. That is beautiful.
Or my favorite, though, is like somebody used this same module. It was just a Tessel and relay modules, and hooked it up to welding machines. And now runs his machine shop based off of web APIs because he didn't want to deal with, I think it's like Windows Me or something that comes on these welding machines. And he didn't want to deal with that anymore. He said, well, I want to come in with my iPad one day and just say, okay, start this process, and monitor it. And now he can.
No way. That's really cool.
Yeah, right?
I mean, if you're a welder, what kinds of things are you monitoring? Or
That's a good question. I think he mostly uses it to turn them on and off, honestly.
Okay.
I mean, that's what a relay does.
Right. Okay. Interesting.
But in theory, you could do this kind of thing in a factory line, too. You could just throw in, I guess, depending on your product, you could throw in sensors that detect whether or not something is passing over it. So like a light sensor, or you could throw in a weight sensor or a climate sensor, and know at different points of a factory line exactly what was going on, and turn that into a dashboard of quality control, like proactive quality control.
Have you talked to users that are actually doing that? Like, I know that sounds like the type of use case that, like, there are entire industries built around, like, companies like Emerson, or just these giant, companies that would do that sort of thing. Have you talked to users that are actually doing that?
Not as much as I'd like to. I've talked to SAP quite a bit, but they're mostly excited about getting people into their cloud, because it turns out that there's a lot of people trying to own big data clouds, but not a lot of people making it easy to get the big data. And so they go around and bring Tehsils to events around the world in order to get people to make data and put it in their cloud.
Is this why you see AWS and Azure developing IoT platforms? Yeah.
And it's interesting because the motivations are a bit interesting. We came in with a very user-centered perspective, and thus we ended up with something that was very easy to use. And they're often coming in with what's the fastest way we can hook it up to our cloud? And they don't necessarily get the whole story of why somebody might be using it, what the challenges are in getting data into the cloud are. So they come in and create these devices that are, a lot of them, very cool, but often a bit tough to use, much in the way of the Arduino and the Raspberry Pi, with the underlying assumption that the people using them are going to be able to do some electrical engineering and often some soldering.
Non-starter.
Yeah, for a lot of people, which is funny because soldering isn't actually hard, but getting a soldering iron and solder and deciding that you're going to learn to solder, that's a pretty big step.
Yeah. So, what is the, when you see users that want to build some kind of full-fledged IoT app and it requires a lot of data processing, data storage, IoT, like time series type of storage, where are they throwing that data?
They're putting it all kinds of places. That's what's kind of cool, actually. So when we built Tessel, we were very intentionally cloud agnostic. We don't want to own the cloud because everybody else is already trying to do that, and those folks have more money than we do. So we see people throw this up into PubNub and Plotly and SAP and Azure. All these clouds are getting used. They're all fighting each other, but they're all cool in different ways. Is that what you're asking?
Yeah, that is what I'm asking. Yeah, I totally agree that there's a lot of combat for this type of thing. But the other thing is, I've spent a lot of time talking to DigitalOcean. They're a sponsor of this show, and I'm a fan of their product. But like one of the things when I talked to their co-founder a bit, he said that there's this big battle for cloud stuff, but that's it's also just because the field is so giant and there's going to be a lot of winners in it. So I don't know, maybe Tessel could go into the cloud IoT business. Maybe if you guys understand it better than, because it sounds like if there's no Heroku for IoT data storage, it could be a big business, but.
Well, I think there are a few, actually. And like I said, so I actually think that the cloud APIs that exist, a number of them are very good and for different reasons. And I think that that's really cool. And I think you're completely right that there's a ton of space out there. And it's a little bit about the companies deciding, okay, we can cater to this particular niche and give up this other piece or any of that stuff. And it's a little bit, it's just waiting for it to settle.
Right. Okay. What is the security model of Tessel? Because we've had some conversations on this podcast with some security experts that are kind of worried about the IoT future of security.
Yeah, that's legit. That's a good question. Fundamentally, with Tessel, we're assuming that if you have physical access, you can get root control. That's just likely to happen. But we have built in some provisions. So Tessel 2 actually is faster to program. Well, so Tessel 1, you actually can only program over USB anyway. So basically that's your own deal at that point. Tessel 2, you can program over LAN. And the way that we've set that up, you have to physically plug it into any computer you want to program it with and exchange RSA keys. And then you should be able to program it remotely as long as you're on the same local area and connection.
Okay. Over Thanksgiving, I had a great idea for a web app. So instead of spending time with my family, I locked myself in a room and I started building this application using Express.js because I love full-stack JavaScript. So I was testing my application locally and I was making great progress. So I decided to deploy it and share it with some of my friends and get some feedback. I used DigitalOcean. I signed up for an account using promo code SEDaily, and in 15 minutes, I had my app deployed to a server and running. It was that simple. This was really the first time I had used DigitalOcean. So if you're like me and you like building stuff and you have ideas for projects, give DigitalOcean a shot. It is the fastest and simplest way to deploy an application that I've ever used. If you want to give it a try, go to DigitalOcean.com and use the promo code SEDaily to get $10 in free credits. Check it out. Tessel uses a MIPS-based board instead of an ARM board, and we don't usually focus on hardware on this show because it's called Software Engineering Daily, but could you give the listeners an idea of the trade-offs between these different boards?
I'm not actually the right person for that question.
Okay, great. Well, I'm not the right person to ask it anyway. Stupid question. What are some of the applications of Tessel that you've seen in the wild?
Let's see. Let me page over to our projects page because I always get inspiration there.
Totally.
It's super fun, actually. Do you know Major League Hacking?
No, what is that?
It's a company that helps colleges sponsor hackathons, and it's kind of in a cohesive way. And so they've done this cool program where they have a hardware workshop, or not workshop, a hardware library. And we've been in it. And that's where I usually see projects all over the web popping up with, oh, somebody made that with Tessel? How weird.
Uh-huh.
Let's see. For example, one I found was facial analysis in retail settings. They used the camera module, and then they ran it through probably OpenCV and tried to learn specific things about how people were reacting to a product or an advertisement.
Wow.
Yeah. Or I love this one from Twilio. We actually worked with one of the Twilio developers because there's a lot of really cool things about a physical device that can both monitor things and text you.
Yeah.
But the example that they made was a sleep tracker for your dog. You can imagine a lot of useful use cases, but this one's cute. And
wait,
they
hold on. It texts you when your dog wakes up?
That is exactly correct.
Why would you build that?
That's a good question. But you might want to know if somebody moves something that's important to you, or, I don't know.
It's hilarious for sure.
This other team, this group from Ubidots made this location-based noise sensor. And I think part of the idea was that you could go around on different streets or on public transit or something and have it consistently listening just to find out where is noisy and where is quiet. And you can see a lot of really interesting city engineering type stuff based on that kind of idea.
Yeah, definitely. So give me the idea of the workflow of somebody that decides to build an app on Tessel.
It's really just a lot like building a Node app. So with the Tessel 2 CLI, we've actually built T2 in it, which is similar to NPM in it. So T2 is just the command you use for our command line interface. And so basically you're making a Node app. So you're going to have a package.json, which includes all your libraries, and you're going to have a base JS file like index.js. And you just type your code in it. So something as simple as var Tessel equals require Tessel to get the hardware. If you have an accelerometer, it'd be like accelerometer equals, var accel equals require the accelerometer library use Tessel.port A, because it's got those module ports and they're labeled. Mm-hmm. And then you're going to do accelerometer.on data, print out the data. That'd be your very simple accelerometer example. And then you're going to get X, Y, and Z console logging to your console every time that it gets data back. And in order to push that code over, you open up your command line and you type t2 run index.js, and then it does.
Wow, that's pretty simple. And then so I guess all of these modules have well-defined APIs to triggering stuff. So if you wanted to take input, or if you want to take output from the accelerometer and feed it into some connected, I don't know, like a light switch or something, presumably if that light switch can connect to Tessel, it's got a module. Like you said, there's a one-to-one mapping between the hardware modules and the software modules.
Yeah. Yeah, exactly.
Okay, that's really cool.
Yeah, it's really fun also because you can... So we aimed for really high-level APIs to our hardware modules. Like the camera one on Tessel 1 is camera.takePicture, for example.
That's perfect.
But if you wanted to get around and mess around at the lower level of it, we actually wrote the drivers in JavaScript. So if you wanted to dig into it, it's github.com/Tehsil, and you can find all the modules there. And you can just dig into the index.js file and, add a function. Maybe you want to take half a picture for some reason. Just get the top half of a picture.
Oh, that's brilliant. So what are the challenges of having an open source community like this? Is it hard to maintain standards across the entire community?
What's more complicated than that, I think, is maintaining a degree of focus. It's phenomenal having this open source community. This is a really great group of people, especially at the core. We've got a Slack channel that we just have an invite link to it on our main GitHub page. And people kind of just wander in there and stick around sometimes. And they end up being really wonderful contributors. I think the biggest problem we've had from open source contribution, though, has been, and I alluded to this earlier, people work on the things that they're excited about, not necessarily the most important things. So as a steering committee member and as somebody who's helping to review PRs and guide what gets committed and what doesn't, it's about making sure that we don't draw core contributors' attention off of major things to work on because they want to make sure and support some minor contribution somebody made that only supports their project.
Okay, so this explains what you're steering. You're steering the open source community.
Yes, exactly. Yeah, and it gets complicated too, right? Because as somebody who's running an open source project, you really want to encourage people to contribute, even if it's some really trivial thing. You want to say, yes, I'm glad you're involved. I love that you contributed, and I will take the time to look at what you did and bring it in. Because that's very exciting. We love getting new people. But the flip side of that is that the people who are reviewing these new contributions are also the people who would be writing the core code if they weren't reviewing those contributions.
Yeah.
So balancing that is really tricky, and it's a really interesting. Honestly, it's a social engineering problem in a lot of ways because it ends up being I'm glad you wrote this, and can I redirect your attention to this, which might interest you, which we're also trying to work on.
So, is Tehsil is it mostly? Well, it is mostly for hackers. I understand that, but are you seeing companies starting to adopt the platform? I know we discussed this a little bit earlier. You said you could potentially use it in a factory setting or something, but are you seeing companies adopt it and use it at scale?
So that's actually what we built it for, more than for hackers. It's obviously should be able to be used by anyone, and that's why hackers adopt it, because you tend to get more early adopters in that crowd. But we built it because we wanted people to be able to build smart device startups. Here's one of my favorite scenarios is, say you have a single web developer, and web devs tend to have startup ideas all the time, like build an app in a weekend, make $1 a month after that. That kind of mindset. What if it was just as easy to do that with hardware? With Tehsil, it is still not, and it's got a long way to go for that. But in a weekend, you could put together a prototype, And you could make a version of your thing, even if you don't know hardware, but you want to make this one device. And you can put it together and say, is this worth making? And you can take that and you can go around to your friends and say, if I made 1,000 of these, would you buy one? Would you use it? Is this the way you would want it to work? And you could take that to potential partners in a startup venture and say, hey, you do electrical engineering. If I made this device, would you be interested in joining me? You can take this to a VC office and have a demo of a hardware device, even without being somebody who makes hardware.
That is such a huge deal. Like, I don't know why I don't spend much time thinking about that fact, but it is not easy to prototype hardware.
Yup. And that's exactly where we're coming from. There's no reason it has to be hard at the first stage. At the first stage, you should be thinking about, is this a thing worth making?
Yeah.
And
yeah,
so
definitely.
that's the way we design this. Is you should be able to answer that question before you need to go invest a lot of learning resources or hire someone who can do electrical engineering or spend thousands of dollars on a run of PCBs. You should first ask the question, is this what I should do?
Have you seen any people prototyping up stuff with Tessel where like they build something out of components that cost $15 and they're like, all right, will would people buy this? And they go and take it to a VC, or they go and take it to person X and that person says, hell yes, I'll buy that for $45. And then they've got a business on their hands.
We haven't seen the full story yet, but we've definitely seen people building prototypes for that purpose. We had a guy build a prototype for a hackathon and win like a big IDEO design award, which is a pretty big deal on a Tessel.
What did he build?
It was a device for helping doctors understand medical needs of a given patient. It was like a wearable device that would have a way for the doctor to access their particular data.
Wow.
Yeah, cool stuff like that. We haven't seen this come all the way to fruition yet, like products shipped with Tehsils in them or first prototypes built on Tessel. But it's pretty encouraging. And I mean, this product has not been out Tessel's not existed for very long, so it's not really surprising.
Tessel's mission is to make hardware development as fast and flexible as developing for the web. What does the world look like when we actually have this in actuality? Like, give me the big picture that you see.
This is a lot of you've probably heard a lot about the IoT buzzword, and I hate that it's a buzzword because usually when people are talking about IoT, what they are saying is they don't really understand what it'll do. I think that what it's changing is the boring stuff. Nest is a canonical, beautiful consumer example, but that's one of few. It's like taking a small thing and making it more intuitive to use. But I think that means we have the potential to build a great number of devices that are more reactive and responsive to us as humans. And you could take this the cynical route. I mean, you can have, depending on which end of this you're on, this is either cynical or really exciting. People building products can put sensors in a product and learn how their user is using it over the course of its lifespan in order to learn more about their user, in order to build better products, that kind of thing. You can end up with products that you buy and continuously update. The toaster is, again, the canonical example of a silly IoT device, but say you bought a toaster and a year later they came out with a software upgrade. And you see this in like Tesla Model S. You get software upgrades to your hardware things, and suddenly you have a thing that is better than it was when you bought it. Which actually, I work at 3D Robotics making the Solo drone, and that's very much true here, as we keep coming out with these really cool ideas, new features, better consistency, more range, that kind of stuff. And we just push it out and say, okay, well, your device that you had a week ago, you still have that device, but now it's better.
What is in the future of Tessel. What will the Tessel 3 look like?
I get asked that sometimes. I think it's a little bit of a false question. We built Tessel 2 because Tessel 1 wasn't good enough, and we knew why. We needed the better Wi-Fi consistency. We wanted more extensibility to USB modules. We needed the ability for industrial applications to have an Ethernet, so wired internet. Tessel 2 is very much an iteration on Tessel 1 because we know how Tessel 1 worked out. Tessel 3, I think, would similarly be, we now have a better technology and a better grasp of what people are trying to do. And so there's no immediate plans to build a Tessel 3 because, as far as we know, Tessel 2 is the best thing there can be.
Do people need a smaller Tessel?
I think for wearables they would. I think that's the most compelling reason to build it smaller.
What is the cost decrease or the size decrease while maintaining the same cost? Like, how does that progress? Is it like a Moore's law type of thing?
What do you mean? On the Tessel itself?
So, I guess how long will it take before we can get a Tessel that's half the size at the same cost?
Well, right
or
now,
how big is the
it.
Tessel 2? How big is the Tessel 2?
It's about the size of a Post-it.
Okay, that's pretty small.
Yeah. It's for a microcontroller, it's not that small, but I keep one in my wallet. I mean...
Yeah. So
smaller would be cool, though.
Smaller would be cool.
I do soft circuits. I've put together some hacked together projects, and like you could put a Tessel on there. You could sew it on. It's got holes around the edges, but it's like a big flat piece, and it's kind of awkward. Yeah, there's a compelling piece of doing something similar to Arduino did with their LilyPad stuff, and it's not the same as the original board. It doesn't have all of the same capabilities, but it's specialized, and that's part of what's cool about it.
You have a background in neural engineering. How did you end up working on open source hardware?
I have a background in neural engineering specifically because I'm interested in building superpowers, by which I mean prosthetics for able-bodied people, which meshes pretty well, actually, with building physical devices.
Sure.
In terms of what I've actually done so far, well, actually, I'm working on a hackathon project next week to do a brain-controlled drone. But most of the time, I end up just learning a lot about how open source and people and hardware all work.
What are the bottlenecks to a fast brain-controlled drone?
I think I'll find that out next week.
Oh, okay. I mean, do we have the technologies there for like a really slow and unresponsive one, or?
I don't think speed is the issue. The drone can go as fast as you want. This particular drone can go 60 miles an hour if we take the safeguards off. I meant the latency between the brain signal and the. Oh, well, I guess all fine.
That's all fine. Okay.
The biggest problem is noise. And this is actually super interesting. So if you start working with connecting hardware to your body, and not in necessarily the scary sense, electrodes are fine, things get really interesting really quickly. The first problem is that the signals that your brain is producing, you can read them through your scalp, but they're very, very small compared to especially like the amount of noise that it creates if you, for example, blink. Because then you're going to pick up the capacitance from your muscles moving, and that's a bigger signal. I actually did a demo on stage. I thought, well, what if we hooked up a Tessel to some electrodes and then hooked that up to a robotic arm and prototyped what it looks like to move a physical device that is far from you by moving your arm. Sounds cool, right?
Yeah.
So I did that. So I hooked it up. It was no problem. I think I programmed it in like an afternoon after I got our electrical engineer to make an electrode module special for me. And I stuck it on my arm, and I started flexing and unflexing, and the arm moved in sync because I only had like the electrodes for a bicep muscle. I kept it simple. Worked great. The problem was, I did this for a talk that I was doing on stage, and as I got closer to my talk time, the less well it worked. And it wasn't because of anything like breaking in the software or the hardware. I put the electrodes on a friend's arm and said, "You try it," and they worked totally fine. What's different is that when you get nervous, your muscles notice. And they do things that you don't want them to.
So you were getting nervous.
Yeah, so when I got up on stage, of course, it just totally didn't work.
Oh, no.
So, I mean, it worked a little bit, but like, that's a more honest representation of my body than I wanted to show off. Because my muscles were doing exactly what muscles do in human situations. So with the drone control, or with the brain-controlled drone idea, what I suspect will happen, and what I'm going to put like a lot of safeguards in on this, but what I suspect will happen is I'll get it up into the air, and I'll think, go forward, and then I'll get distracted, and then it will do something totally different and spastic.
So I came from the world of biology to computer science, and the thing that I feel is the biggest shift moving from biology to computer science is in biology, everything is a big black box. Like, we don't know how any of this stuff works. Like, we've got some idea, we've got some like correlations, but by and large, we don't know how this stuff works. We don't know how this body we're walking around, this big bag of water, we don't understand how things are actually going on. So, I mean, from your experience, from your background in neural engineering, do you think, like, in our lifetime, are we actually going to understand this stuff well enough to build good interfaces? I mean, like, the interfaces between the brain, if you build a brain-controlled drone these days, I mean, I assume that the interface is really, like, kind of skin deep. Like, it's not really interfacing at the level that we would expect our brain to be interfacing with actual parts of our body.
Yeah, of course. Well, what was really cool is that you don't actually have to learn how the brain works in order to use it. And that's the single coolest part, is you can actually train yourself, you can train your brain to accept inputs that it's unfamiliar with, and have it start learning to use them the same way that it uses your own muscles. And there's all kinds of really cool examples out there. I think a lot of people have seen the video of, like, somebody had a headset that controlled a robotic arm, and they were paralyzed, and they were able to, like, get the arm to pick up a milkshake and feed them through a straw, like, without anyone helping them. That's very compelling. Your brain doesn't have a part of it that says use a robotic arm. Your brain has a lot of signals, and through enough focus and training, you're able to make those match up to move a robotic arm. Or somebody's done this with, I forget what it was. I think they hooked up a camera and hooked that up to some like cell phone vibrator motors, which were stitched across their back on a suit, so that they could learn to see basic shapes from behind. Through the pattern that was created on their back muscles. So you can actually have some really crude interfaces with the brain that actually work. You just have to figure out a way to get it in, and that's any nerve in your body. And then you have to figure out, of course, if you want to control something with your brain, you have to figure out a way to get it out, which is harder.
Yeah. Okay. Well, okay, that's great. That's a super interesting tangent. We could talk about that for a long time. Kelsey Breseman, thanks so much for coming on Software Engineering Daily. It's been super interesting talking to you about Tehsil. I'm a huge fan of the work you guys are doing, so thank you so much.
Yeah, thank you so much for having me. This has been fun.